You're floating, not in water, not in air, but in something much older, much wider, space, black and calm, dotted with stars, scattered like frozen sparks. You look around, and at first, everything seems still, silent, cold, peaceful, but the peace is a kind of illusion. Because space is not frozen. It moves. It grows. It stretches. You are not just floating through space. You are floating on it, like a leaf resting gently on a vast, invisible tide. And that tide is carrying you farther and farther from everything else. The universe is expanding. It always has been. It still is. And today, you're going to drift along with it. Not like riding a rocket, not like racing toward a destination. No. This expansion is quieter than that. Slower, gentler. It's like standing on a stretch of fabric that is slowly being pulled from all sides. You don't feel it under your feet, but everything around you begins to drift away. Galaxies are moving apart, not because they're flying through space, but because space itself is growing between them. It doesn't stretch into something else. It isn't expanding into a room. Space is not inside something. It is the something. It expands within itself. Imagine this. You draw dots on the surface of a balloon. As you inflate it, the dots move away from each other. They're not moving on their own, but the surface beneath them is growing. Now imagine the balloon has no edge, no outside, just a surface, endlessly stretching. That's space, except it's not two-dimensional, and it's not inside a room. There is no outside to the universe, at least none we can reach, none we can measure. The expansion isn't happening somewhere out there. It's happening everywhere. Even the space between atoms is subject to this expansion, though held together by forces much stronger, like gravity and electromagnetism. But over vast, intergalactic distances, that subtle stretching builds up, and over billions of years, galaxies that were once close companions drift further and further apart. You might ask, why? Why is the universe expanding? Why does space stretch? What's making it do that? The truth is, we don't fully know. We've given names to the forces at play, dark energy being one of them. A strange pressure, a force that seems to push space apart, even as gravity tries to pull things together. But a name isn't the same as understanding. And for now, it remains one of the deepest mysteries in physics. We do know this. It began with the Big Bang. Not an explosion in space, but the sudden expansion of space itself. From a single, hot, dense state came everything. Time, matter, energy, distance. Space didn't expand into anything. There was no before. Time began with that expansion. And you, floating here now, are still riding the wave that started it all. Every second, every breath, you're moving. The space between you and the Andromeda Galaxy is growing. Between you and the edge of the observable universe, light is being stretched so thin it becomes invisible. Galaxies are running away from you, not by force, but by fabric. It's a quiet race. No sound, no resistance, just drift. This might feel lonely. Galaxies parting ways, stars fading, distances growing too vast to cross. But it's not loneliness. It's rhythm. It's breath. The universe is breathing out. Maybe one day, billions of years from now, it might breathe in again. Or maybe it will stretch forever. But for now, you're floating on a living universe, expanding quietly beneath you. A slow cosmic tide that began before time had a name, and you're still riding it. The universe is expanding, but it hasn't always looked like this. Calm, wide, scattered with galaxies. In the beginning there was no sky, no stars, no distance, only heat, only energy, only possibility. The story begins with what we call the Big Bang, though it wasn't really a bang at all. There was no explosion in space. because there was no space to begin with. There was no blast from a center, because there was no center. No edge, no outside, just a beginning of everything. In a fraction of a second, space itself expanded outward, faster than light, unfolding like a silent ripple in every direction. This was cosmic inflation, a mysterious, violent growth spurt, where space ballooned outward unimaginably fast, not through anything, but through itself. During this time, matter didn't yet exist. There were no stars or galaxies, just energy, dense, hot, unshaped. Then slowly, it cooled. And as it cooled, that energy condensed into the building blocks of the universe, particles, atoms, light. Time passed. Gravity, gentle but persistent, began to sculpt. Small clumps of matter became clouds, clouds became stars, and stars gathered into galaxies. The universe found structure, a kind of rhythm, and yet it never stopped expanding. Even as stars were born, even as galaxies collided and danced, space itself continued to stretch, pulling everything apart as it held everything together. We can still hear the echo of that early moment, not with our ears, but with our instruments. A faint glow of leftover radiation, the cosmic microwave background, still lingers in every direction. A perfect whisper from a younger universe. This glow shows us how far we've come, from fire to dust, from chaos to galaxies. The expansion continues, slower now than during inflation, but steady, persistent, and the more we learn, the stranger it seems. What drives the universe to expand? Why does it not slow down, even as gravity tugs gently on its threads? We name the cause dark energy, but names do not equal answers. Still we watch, still we measure, still we wonder. The expansion is not history, it is still happening. And the universe we see today is only one frame in a film that hasn't finished unfolding. Everything is moving, not with noise or urgency, but with silence, a kind of slow motion that takes billions of years to notice. You are surrounded by galaxies, spirals, ellipses, clouds of stars, each one a city of suns drifting further and further away from the others. It's not because they're flying through space. It's because space is stretching between them. And that stretching never stops. It doesn't pulse. It doesn't rest. It just continues. Quiet. Constant. This is the silent drift. Imagine a raft on a slow, endless ocean. You don't feel the movement at first. There's no wind, no waves. But if you watch the stars long enough, they begin to slip away. Now expand that raft to the scale of a galaxy, and replace the ocean with space-time itself. This is the reality of the universe. Galaxies aren't speeding through a cosmic highway. They're passengers on a moving road. The more distant a galaxy is, the faster it seems to move away. Not because it's going faster, but because there's more space stretching between us and it. This is called redshift. Light from faraway galaxies gets stretched as it travels, its wavelength lengthening like a rubber band. It shifts toward red, a cooler, fainter, older color. The farther a galaxy is, the redder its light becomes. Eventually, it slips beyond the visible, and then beyond detection. Not because it's gone, but because its light can no longer reach us. It's like watching a ship disappear over a curved horizon. You know it's still sailing, but the distance makes it invisible. Every second, more galaxies fade beyond the edge of what we can ever see. They aren't moving out of reach. Space itself is carrying them there. This edge is called the cosmic horizon, a boundary of what is observable, not of what exists. It's not fixed. It's always changing. And beyond it, there may be countless galaxies we will never know. This isn't a sad thing. It's just the nature of expansion. A universe so vast that some parts will forever remain silent. And so we drift, Not by engines, not by propulsion, but by being part of space itself. We're not just in the universe, we are of it. And every moment, the distance between everything grows just a little more. Not loud, not fast, just quiet and constant. The silent drift continues. There's something you can't see, not because it's hidden behind a wall or buried in darkness, but because its light simply can't reach you. You live inside a bubble, not a shell of glass or metal, but a sphere of visibility, an observable universe. Beyond it, things may exist. Galaxies, stars, planets, even entire structures made of billions of suns. But their light hasn't had time to reach you, and in some cases, it never will. Because as space expands, light traveling across it is stretched, slowed, and eventually left behind. This is the invisible horizon, a quiet edge drawn not in space, but in time. Light has a speed limit, roughly 300,000 kilometers per second. Fast, but not infinite. Even something moving at that speed takes time to cross the universe, to travel across galaxies, to reach your eyes. When you look up at the night sky, you are not seeing stars as they are. You are seeing them as they were. A distant star may be 1,000 light years away, so you see it as it looked 1,000 years ago. Look farther, and you see further into the past. The light from a galaxy, 10 billion light years away, shows you that galaxy when it was young, when the universe itself was only a fraction of its current age. You're not just looking across space, you're looking back through time. And yet, there's a limit. Beyond a certain point, light from distant galaxies is being pulled away by the expansion of space faster than it can travel toward you. No matter how long you wait, that light will never arrive. It's not because it's moving too slowly. It's because space itself is outpacing it. A moving walkway that grows faster than your steps. And so, there are galaxies whose light will never reach you. Not because they are gone, but because the road between you and them has stretched too far. You might imagine this like standing in the middle of an infinite plain. All around you, the land rolls out forever. But the air is thick with fog, and that fog grows denser with distance. You can see only so far, and beyond that, everything fades. The universe is like that. Not fogged, but stretched. Your horizon is defined by how far light has come since the beginning of time. Roughly 46 billion light years in every direction. That's your cosmic bubble. Not because the universe ends there, but because your ability to observe it does. This horizon is expanding, but paradoxically, it also hides more. As galaxies drift farther away, their light stretches into longer wavelengths. First into infrared, then into radio, then beyond all detection. They vanish not in a flash, but in a slow dissolve into invisibility. We call this redshift, but it is more than a color change. It is the loss of connection. Over billions of years, the most distant galaxies will slip from view. Their light will fade until even the most powerful telescope cannot see them. And in time, our local group of galaxies will be all that remains visible, a cosmic island in a dark, expanding sea. Still, beyond the horizon, the universe continues. What lies there, we may never know, not because it's unreachable, but because time itself cannot carry the message. Some scientists suggest entire realms of space exist beyond our bubble, galaxies stranger than our own, cosmic events we'll never witness. And further still, maybe other universes altogether. But within this horizon, we are gifted a view, a window into the structure of everything we've ever studied, measured, or imagined. And it is enough. Enough to know that the cosmos is vast, beautiful, and full of motion. Even if most of it is destined to drift quietly beyond the edge of what we can ever see, the sky seems endless. But even the stars we see now are not forever. They burn, they shine, they live, And then, like everything else in this universe, they fade. This is the slow unraveling of light, a future not filled with fire but with quiet. The universe continues to expand, and with each passing moment, galaxies drift further apart. Right now, galaxies still dance together in clusters, spiraling, merging, exchanging stars like gentle tides. But over time, these dances end. Gravitational bonds weaken, distances grow, the great web of galaxies pulls itself thin. Billions of years from now, those distant galaxies, the ones we can barely see, will vanish completely. Not in an explosion, but in silence. Their light will stretch so far that it no longer reaches us. The cosmos will feel emptier, though it's still full of galaxies we can't see, stars we can't reach, histories we'll never hear, and then the stars begin to go out. Not all at once, not dramatically, but slowly, patiently, one by one, they exhaust their fuel. Some collapse into white dwarfs, small, dim embers that cool for trillions of years. Others explode in a final burst, leaving behind neutron stars or black holes. But no new stars are born. The raw material, the gas and dust of creation, is used up, locked inside long-dead remnants. Galaxies grow darker. Their arms unravel, their shapes dissolve. What remains is a quiet realm of cold matter and memory. This is called the degenerate era, a time when all the stars have died. The universe becomes a graveyard of stellar corpses, white dwarfs, neutron stars, black holes. They float, dim and scattered, through ever-expanding space. Occasionally, they may collide. Two black dwarfs merging in a silent ripple of energy, a brief light in an age of darkness. But these events are rare. The space between everything grows wider still. The universe becomes still. Eventually, even the faintest glow fades. White dwarfs, once warm, become black dwarfs, cold, invisible stones drifting in the dark. There are none yet in existence. It takes trillions of years to cool this far. But in that distant era, they will fill the cosmos, silent reminders of stars that once were. There is no heat, no new light, only particles and time. This far into the future, even black holes are beginning to change. They seem eternal, massive, immovable, but slowly, over incomprehensible timescales, they begin to evaporate. Not quickly, not violently, but atom by atom, through a strange process known as Hawking radiation. They lose energy, they shrink, they disappear. A trillion years from now, even these titans will vanish, and with them, the last shadows of the past. What remains is a universe without light, without warmth, without structure. Just drifting particles, cold photons, and the slow ticking of time. This is called the heat death. Not a burning, but a cooling. A total stillness. Entropy has reached its peak. All energy has been spent. Nothing more can happen. No stars, no life, no movement, just calm. This isn't a death in the traditional sense. It's not tragic. It's not violent. It is a long exhale, a natural conclusion to a universe that once burned with brilliance. And yet, even in this darkness, there's a strange beauty, a kind of peace. The universe doesn't end in fire. It ends in quiet. The stars had their time. The galaxies sang their songs. Now all is still, and space, ever stretching, remains. The stars are gone. The galaxies are dim. The sky is no longer filled with light, only with shadows and space that stretches endlessly in all directions. But something still stirs in this quiet universe. Not stars, not planets, not fire, but gravity. Dense, invisible, relentless gravity, wearing the shape of black holes. These are the remnants, the last active forces in a silent cosmos. Born from the deaths of massive stars, or the merging of galaxies long faded, they now rule the darkness. Black holes do not shine. They do not shimmer or glow. They absorb. They wait. They endure. Some are small, only a few times the mass of a star. Others are giants, supermassive black holes millions or billions of times heavier than the sun. They rest quietly at the centers of ancient galaxies, or drift through empty space where galaxies once were. They are patient, because black holes measure time not in years, not in millennia, but in aeons. In this new era, the black hole era, they are the final engines of cosmic motion. Occasionally, two will find each other, drawn together over vast, cold distances. They spiral inward for millions of years, then merge in a burst of invisible waves, a ripple through space-time itself. Gravitational waves, not light, not sound, just a vibration of existence, a whisper in the fabric of reality, and then they become one, larger, quieter, still. But black holes do not last forever. Even they have a limit. Though they seem eternal, even they fade. Not quickly, not dramatically, but slowly, beyond imagination. A black hole emits no light, but around its edge, something strange happens. Quantum particles flicker into existence, pairs appearing from the vacuum. One falls in, one escapes. Over time, this tiny imbalance causes the black hole to lose mass. This is Hawking radiation. It is not heat, not in the usual sense. It is the slowest kind of evaporation, like a mountain crumbling grain by grain over a trillion years. The larger the black hole, the longer it takes to vanish. Small ones go first, then the medium ones, and finally, the giants. The supermassive black holes, shrinking imperceptibly until nothing remains. Imagine a black hole, cold and vast, alone in a universe so stretched that even light is a rarity. No stars, no galaxies, just silence and curvature. And still, it loses mass, bit by bit, until the last particle escapes, and the whole is gone. No bang, no flash, just absence. When the final black hole evaporates, there is no more gravity in motion, no more matter collapsing, no more heat to transfer, just particles drifting through expanding space. So cold, so far apart, they almost forget each other exists. This is the end of all structure. The universe has gone dark, not in anger or tragedy, but in fulfillment. It has finished its story, and the black holes, the quiet archivists of that story, have left no trace behind. But in their time, they carried weight. They carved galaxies. They shaped stars. They held time in their grip. And in the end, they gave back everything they held. The final exhale of a universe that once burned. The universe is still expanding, but not the way it once did. There are no stars bursting into life, no galaxies colliding. No heat, no color. The structures are gone. The lights have gone out. And what's left is something even quieter than darkness. A final state. Stillness. Not from absence, but from completion. This is what physicists call the heat death of the universe. A phrase that sounds dramatic, but is actually gentle, soft, gradual, not fire, not explosion, but an ending born of exhaustion. Everything that could happen has happened. In this far future, the universe has reached maximum entropy. Entropy is a measure of disorder, of energy that can no longer be used. It's not destruction, it's just diffusion. A hot cup of tea cools down in a cold room, not because something was lost, but because heat spreads out, balances, equalizes. Now imagine the universe as that tea. After trillions upon trillions of years, its energy has spread so thin that no contrast remains. No hot, no cold, just balance. And in that balance, nothing more can be done. No new stars, no reactions, no information that can change. The particles that remain are scattered across unimaginable distances. Protons, electrons, neutrinos, ghosts of what once was. Even light still exists, but stretched so far by expansion that it's effectively undetectable. Its wavelengths longer than galaxies, its energy spread too thin to warm even the emptiest void. It moves, but it does not build. Nothing changes. It's tempting to think of this as a kind of death, and in some ways, it is. But not in a tragic sense. There's no pain, no loss, just the universe reaching the end of its ability to do work. All the gradients have faded. Every difference has been smoothed. It is peace. Time still flows, but without events it loses meaning. No tick, no tock, no dawn, no dusk. Just endless duration. The arrow of time continues forward, but with nothing left to carry along. No stars to orbit, no galaxies to spin, no black holes to pull or to fall into. Just space, expanding still, but so empty that the word empty no longer feels quite right. Is this the end of the story? In the classical view, yes. A quiet, endless expansion. No new structures, no reset. The universe does not collapse. It does not restart. It simply fades, more slowly than we can imagine, until even the idea of change feels distant. And yet, even here, on this cold edge of cosmic thought, questions remain. What happens to information? Do particles flicker with purpose, even now? Could random fluctuations spark something new? Is this truly the end, or is it the soil for a future we cannot yet describe? Some theories say this isn't the end at all, just one phase in a cycle of universes, a breath that one day we'll inhale again. Others say quantum randomness might, given enough time, generate a new spark, a fluctuation in the void, the seed of a new universe. We don't know, and maybe we never will, but perhaps that's not a flaw. Perhaps the mystery is part of the beauty. The heat death is not loud. It doesn't need to be. It is the quiet echo of a universe that did everything it could, that expanded, created, burned, collapsed, and finally let go. In its silence, there is completeness. In its emptiness, a strange kind of fulfillment. Everything ends, not with noise, but with balance. The universe has gone quiet. Everything is stretched, thin, still, cold. No more stars to shine, no more galaxies to form, no more black holes to pull at the edges of space. Entropy has won. The gradients are gone, and the universe rests in a perfect, permanent balance. This is the heat death, the grand silence after a symphony of light. But a question still lingers. Is that the end? We often think of endings as permanent, a door that closes, a chapter that finishes. But in physics, especially on the largest and smallest scales, endings can be less clear than they seem, and sometimes endings are beginnings in disguise. Let's go deeper, not into space, but into possibility. Even in a universe that seems still, there is motion. There are quantum fields stretching across all of space. They don't disappear, they fluctuate, tiny random flickers. Invisible to the eye, but always there, like the rustle of leaves on the quietest day. These flickers are called quantum fluctuations, brief spontaneous changes in energy, born from nothing, and gone just as quickly. Most of the time they are small, too small to matter, but over vast amounts of time, they could matter. Because in a universe that lasts forever, even the rarest event has time to happen. One idea, wild but possible, is that a fluctuation in the vacuum of space could one day create something, a particle, a spark, a tiny bubble of new energy. And if that bubble contains the right conditions, if the physics inside are just right, it could inflate, rapidly, violently. It could become a new universe, a new space, a new time, a new beginning. This is the idea of vacuum decay or cosmic rebirth, a fluctuation that triggers a reset, an echo of our own Big Bang, but born from the ashes of another. Of course, it's only a theory. No one has seen it. No one may ever see it. But the math suggests it could happen, and in an endless empty universe, even the smallest chance has an infinite runway. Another idea suggests that the universe doesn't just end, but loops. Over time, the cosmos could fold back on itself, not like a circle, but more like a breath. Inhale, exhale, expansion, contraction, a cycle of time itself. This is known as the cyclic model, a series of universes, each born from the death of the last. Not reincarnation exactly, but repetition on a cosmic scale. Each universe may be different. New laws of physics, new constants, new stars. But the rhythm remains. There's even a theory that the universe is one of many. Not metaphorically, literally. A multiverse, an infinite collection of universes, each with its own beginning, its own end, its own reality. In this view, our universe's expansion is just one ripple in an endless sea. We are a bubble among bubbles. And perhaps, long after our bubble fades, others will still be forming, growing, expanding. The ending of one is just a continuation of another. And then, there's the most profound possibility that this is the end, that the universe will drift quietly forever, unchanging, unfeeling, unmoving. And that's okay too, because endings don't need to be undone to be meaningful. Sometimes stillness is its own kind of beauty. The universe has written its story, from plasma and particles to galaxies and life to emptiness. And that story matters, even if it ends in silence. So, is it the end? Maybe, maybe not. No one knows for certain. And perhaps that's the most cosmic truth of all, that in a universe filled with time, space, matter, and possibility, some questions remain open forever. The universe feels vast, galaxies beyond counting, stars too many to name, distances too large to hold in thought. But what if it's not alone? What if everything we see, everything we know, is just a single thread in a far larger cosmic tapestry? This is the idea of the multiverse, a reality not made of one universe, but many, perhaps infinite, each one separate, each one distinct, each one with its own laws, its own physics, its own fate. In one version of this theory, our universe is a bubble, a curved, expanding pocket of space-time floating in a vast cosmic foam. All around it, other bubbles, other universes, some born before ours, some yet to form. They don't touch, they don't collide, they simply exist, side by side, forever out of reach. In one bubble, gravity might be stronger. In another, atoms may not even hold together. And in yet another, stars may form and vanish in the blink of an eye. We know only one, ours. But it may not be the only way the cosmos can unfold. Some physicists call this the inflationary multiverse. It comes from the idea that cosmic inflation, that moment of rapid expansion after the Big Bang, didn't just happen once. It's still happening, continuously, in pockets. Every so often, a new universe buds off from the inflating fabric. It cools, it slows, and it becomes something new, just like ours. That would mean new universes are forming even now, far beyond our observable horizon. We cannot see them, we cannot reach them. But if the math is right, they're out there. Another version comes from quantum physics, the world of the very small, where particles don't behave like objects, but like probabilities. In this view, every outcome, every possibility, every choice splits the universe, a branching tree of infinite paths. You go left, you go right, and the universe splits in two. one where you turned, one where you didn't, and it keeps branching, not just for people, but for atoms, stars, galaxies. Every quantum event creates another fork. This is called the many worlds interpretation, and it paints reality as a garden of possibilities, all real, all existing, all forever beyond each other's sight. So what does this mean for us? It means the end we spoke of before, the heat death, the fading of light, might only be an end here. Elsewhere, in some other universe, the story might just be beginning, or it might be wildly different. A place where time flows in two directions, where light slows down, where matter is made of something we can't name. Maybe there are universes where life never began, or where it took on forms unimaginable, or maybe even one where it never ended. And beyond the multiverse, there are ideas stranger still. Mathematical landscapes so abstract that universes are just one solution among infinite equations. Dimensions curled beyond perception, brains floating in hyperspace, cosmic cycles without beginning or end. Ideas so far from everyday experience, they feel like myth, but grounded in real working physics. Because even here, at the edge of what we know, we're still guided by patterns, by math, by curiosity, by the desire to understand. Whether the multiverse is real or not, it asks something of us, to think bigger, to imagine more, to accept that our universe, for all its vastness, might just be a small piece of something larger. And that can be comforting, because if there are many universes, then this one, with its galaxies, its people, its questions, is not alone. It's part of something infinite, a cosmic mosaic, a chorus of existence. So we look up, and we wonder. Not because we'll find all the answers, but because the wondering itself is part of who we are. In a universe that may be one of many, our questions echo farther than we can see. And maybe, somewhere beyond the invisible horizon, those echoes are heard. You've traveled far, not with ships, not through tunnels or wormholes, but through time and thought and space beyond imagination, from the Big Bang to the death of light, from the lives of stars to the stillness after entropy. You've seen black holes form, watched galaxies drift apart, and imagined what may lie beyond the end of even time itself. And now, we return, not to Earth, not to one place, but to something even more familiar, to you. Because the most astonishing fact is not just that the universe is vast, but that you are part of it, not separate, not just an observer. You are made of it. You are made from it. Every atom in your body was born inside a star, forged in nuclear fire, shaped by gravity, released by explosions, scattered through space, and eventually drawn together into what you are now. You are not in the universe. You are the universe, thinking, questioning, feeling. You are atoms with memory, stardust with consciousness, a small, fleeting configuration through which the cosmos can know itself. Your heartbeat, your breath, your thoughts, they all echo the laws that shaped galaxies. The same gravity that pulls planets into orbit also holds your feet to the ground. The same electromagnetism that binds atoms lights your brain with sparks. The same elements found in stars live in your bones, your blood, your voice. When you speak, the universe listens through you. You might feel small. After all, the cosmos is enormous. It stretches beyond visibility, beyond understanding. But your smallness is not a flaw. It is a perspective. To be aware of such a vast reality, that is not weakness. That is wonder. A grain of sand can still know the ocean. A moment can still hold eternity. And you, brief though you are part of something so much larger than time. The universe is not a cold, distant thing. It is within you. Its patterns are in your DNA. Its vibrations move through your thoughts. Its history is your history. You are a child of collapsing stars. A story written in hydrogen, carbon, calcium, iron. You are not outside the story. You are a chapter in it. A line in the poetry of matter and energy curving through space. And just as you came from it, you will return to it. One day, the atoms that make up your body will fall apart. They will drift, rejoin the earth, join the air, the water, the roots of trees, maybe even the stars again. Nothing is wasted, nothing is lost, just rearranged. You are temporary, yes, but the parts of you are ancient, and they will go on. And so, as the universe expands and cools and changes, you have been here for a moment. You have opened your eyes inside a galaxy. You have looked out into the deep, and you have wondered. That matters, because the universe doesn't just exist, it experiences, through stars, through planets, and through you. So take one last breath in this journey, and remember, you are made of 1,000,000 miracles, of laws and accidents woven into something brief and beautiful. You are the result of 13.8 billion years of movement. And for now, in this small pocket of time, you are awake.